Our next speaker is Pedro Tabacof. He is a staff machine learning scientist at Intercom in Dublin. His talk will be about, he wants to use his skills in machine learning to place bets on Counter-Strike matches. Based on the title, we can already kind of guess how that turned out, but I think there are a lot of lessons to be learned here that he wants to share with us, and that's what this talk will be about. So please give him a big round of applause.
Thank you. Well, the title says it all. Just a word of warning, this is a lot more about machine learning than it's about Python, but we did use Python for every single thing here, modeling, scraping, making the bets, so it fits PyData. And just a brief introduction before I begin. I'm a machine learning scientist at Intercom. We are hiring. Since we are not sponsoring this conference, I won't spend too long here, but come talk to me afterwards if you're interested. You must relocate to Dublin, unfortunately. And let's talk about the elephant in the room. Did I actually lose 1,000 euros? Is that a marketing gimmick? I did. I even went back to the betting logs from 2019 to plot the cumulative returns that I had from the betting website. And as you can see, I lost a lot of money very quickly in 1 or 2 weeks or so. And then my losses plateaued for like 2 months until I decided to call it quits. So why should you listen to me? Am I not just a failure? Why am I in front of you? Well, I think failure stories can be a lot more illuminating than success stories because, well, in success, there's always luck. There's always survivorship bias, as the plane implies. And when you fail, you can actually be very honest and transparent with like what you learned, what you did wrong, and why. And maybe also did some things correctly. So before we get to CSGO betting, let's talk a bit about sports betting with machine learning more basically. I need to cover some theory before we get to the practice. So the first lesson is that you must have an edge. If you don't have an edge, you are the edge for someone else. So what is an edge exactly? It's some kind of market inefficiency that we're going to explore for monetary gains. That kind of implies that the efficient market hypothesis is wrong. And the efficient market hypothesis is a pretty good approximation for pretty much anything financial. So you really need to know what you're doing. We have to have like strong evidence, have to have a lot of clarity on what is your edge. And you cannot just buy it, you cannot just find it in a PyData talk. You must come up on your own and really drill into it. And what was our edge, or so we believed? Quite naive, but we thought machine learning was our edge. We thought that, well, this was 2019, was a little bit less hyped than today, and not many people were applying machine learning to like financial decision making, but we were, this we is me and my friend who worked on this. And I was working in a fintech, using LightGBM and XGBoost to influence literally billions of dollars of credit exposure. Unfortunately, not talk too much about it in public, and was bringing a lot of profits to the bank. And I thought, why shouldn't I just use this kind of knowledge directly for me, for my own benefit? And that's the edge that we believe that we had. Well, if you want a deeper discussion on like what is an edge for, with an accessible perspective, I really recommend this book, Laws of Trading. And by the way, don't bother like taking notes because I'm gonna link like a QR code later where you can find all the references. There are like 2 blog posts with this presentation. So how can you use machine learning for financial decision making? It all starts with a very simple profits equation. If you're in finance, you might think that this is too simple. Where is like time value of money? Where is like a risk-free interest rates? But I really suggest always starting with this equation, no matter what is your application. This can be always very illuminating. Let's see some examples. So first one, I mentioned I was working in a bank. How can you like define profits and losses when you're giving like out bank loans, when you're giving out credit? So we have two terms. The first is the revenue, what the bank gets. And here it's going to be proportional by the revenue of the loan times the interest rate that the bank charges. So here we have one quantity that depends on the customer. They're going to decide how much they want, or maybe you can cap that. And then there is the interest rate, which you can define as the bank. And the losses, or the expected losses here would be how much you're giving times the probability of a default, of them not paying back. We have a very similar view for credit card fraud. I also worked for e-commerce, that there was a lot of fraud that was in Brazil. And you get like something that's proportional to the margins of each transaction, but you lose all of the transaction when there's a fraud. So here you can already see like a lesson. if the probability of fraud is greater than your margins, you don't have an e-commerce business, which is a big problem like South America. And finally, for betting, it's also similar. You get how much you bet, of course, times the betting odds, which is given by the bookies, by the betting house, and times the probability of winning the bet. And your loss, of course, how much you bet times probability of losing, which is nothing more but the complement of 1 minus winning. So machine learning can help fill in the blanks. There are a lot of quantities here that are either decided by the customer or decided by the business. There's a causal inference problem there. But there are some quantities that we really don't know exactly. And here are the probabilities. The probabilities of like a default, of fraud, and of winning the bet. And that's where machine learning can help. You can use models like LightGBM, XGBoost to estimate those probabilities. And then you can plug into this equation the other quantities you can either plug in or control, and now you have a financial decision-making system. This is, of course, very naive, but that's the gist of it. So when I say probability of winning, probability of default, what does that really mean? This is actually a question that I ask a lot of candidates when I interview, which is, if you have a logistic regression and that gives you, after predict proba, a 0.7 value, what does that really mean? Does that mean that it's correct in saying the true class 70% of the times? Well, that depends on whether the model is calibrated or not. If it's calibrated, you can trust the scores as if they were probabilities. If it's not, you can't. And luckily, most models are pretty well calibrated, like logistic regression is mostly calibrated out of the box. Even the same applies to LightGBM, XGBoost, depending on your loss function. So models like SVM are totally uncalibrated. It really depends on a case-by-case basis, but you should always, no matter what, look at the calibration curves, calibration plots. You want to know how the model is performing in terms of like probabilities, if you want to use this probability for decision making. And just something important to note is calibration is not enough. If you have a coin flip, you say it's 50% chances of heads, you're perfectly calibrated, but your accuracy here is no better than a chance. If you want to understand this a little bit more intuitively, I really recommend the book Super Forecasting. It really talks a lot about like forecast and calibration. Now let's go to like making some decisions for bets. When should you bet? The decision is quite simple. If your model says the probability of winning the bet is greater than the probability implied by the betting odds, you should make a bet. Let's skip this equation. I don't want to bore you too much. And let's take one following example. Let's say that you have 2-to-1 odds given by the betting house. This means that if you put in $1, you get $2 back if you win the bet. And 2-to-1 odds implies that the probability by the bookmaker is only 33% of winning. You can easily prove that, and this means there is a discrepancy here. My probability of winning, which is subjective, is greater than the bookmakers. And thus I decide to make a bet. So let's say that I bet $100. The expected returns here, the expected profits is $50, an ROI of 50%. That's pretty amazing, right? Of course, it's all like a fake situation. But here I showed you how to like decide whether to make a bet or not. That's quite simple. But how much should you bet? Should you bet $1, $100, all your bankroll? There is a solution for that, which is typically called used as the Kelly criterion. The Kelly criterion is a formula. It's very simple. I won't show you here, but you can see in the blog post. And what the Kelly criterion does is give you how much to bet for each bet, given the probability of winning and given the odds. And it's going to maximize your log wealth. That sounds a bit weird, but just some clarity here. In finance, or when you're talking about money, you generally care about the log utility of money, not the absolute value. Let's say that you have 1,000 euros in your bank account. If you lose 100, that's a big deal, that's 10%. But if you have 1 million euros, you lose 100 euros, that's nothing. And the log wealth captures that. That's what you want to maximize over time. And also it prevents risk of complete ruin. So in this example that I just showed you about 2-to-1 odds and that your model says it's 50% probability of winning, Kelly criterion suggests to bet 1/4, 25% of your bankroll. That's a lot. That sounds even a bit suspicious. Just one bet, I'm going to bet, but 1/4 of all the money that I have. Yeah, you probably don't want to use Kelly, even though it's like a very typical recommendation. It's way too aggressive, and most importantly, it does not account for the uncertainty. The probability that we're using is just but an estimate. The probability is going to be wrong many times. Hopefully, on average, if it's calibrated, it's not, but still, for each individual bet, it might be wrong. And if there is a discrepancy between the odds and your probability, what is more likely to be wrong? Is that your model, or is that like the bookmakers like probability? So here I have like a visual display of like how Kelly is very aggressive. You see on the y-axis is how much your bankroll is going to grow over time, and on the x-axis is how much you're going to bet off your bankroll. And this is for the same example. So the optimal point here is 25%, and your bankroll grows at 6% rate. If you just slash that by half, you still have a pretty good, pretty healthy increase of like 4%, but with much lower risk. However, if you double your bankroll age, you are pretty much at zero, and you can easily get into like negative returns. So there's a deep asymmetry here. You probably want to go to the left side, not to the right-hand side. And there's some suggestions, like typical ones use the half Kelly, which is just get the Kelly output and divide by half. That's what I actually use, and that's how I lost money so fast, because that's still quite aggressive. Just not as aggressive as the original one. I would have lost money even faster with the full Kelly. And maybe my recommendation here is just start with a fixed amount. You don't really care about your log wealth if you're starting to bet. Just do it very simple, start with like just the same value for all bets, and get a lot of confidence in all the parts of the system, including the probability, and then you consider something more advanced like Kelly, especially if your bankroll is fluctuating a lot. And finally, I already mentioned this, like if there's a divergence between your probabilities and the bookmaker probabilities, it's likely that you are wrong here. And what if you are only making bets when that happens? Even if your model is perfectly calibrated on average, if you only make bets when your model is overestimating the true probability, you might have terrible bets every single time, even though your metrics were perfect in the test set. So this is called the winner's curse, more broadly, and that happens to any kind of auction. I have a simulation here that we have 10 unbiased bidders, and they all know the true value on average. They all have the right expected value, but just some small noise. And the winner of this auction is gonna overpay by 5% on average. And that's intuitive. The winner of the auction is the person that believes the item has the most value, and that makes them more likely to overpay. It's some kind of selection bias, and that happens to betting as well, because as I said, if you only make bets when your model is very confident, you're probably overconfident. And the way to handle this, there's no silver bullet here. You just gotta validate your strategy, your betting strategy, very carefully. There are two things I recommend, one that I did, one that I didn't do. What I did, I'm gonna show you, is the backtest. It's replay matches past betting odds using your betting strategy and see what your financial and machine learning outcomes would have been. But more importantly, you should always, which I didn't do, paper trades, which is put your system in place end-to-end and make your bets or decisions in shadow mode, and then collect all the data after some time, maybe a month or so, and compare against your backtest. If moving forward in time, your decisions don't represent the backtest is probably wrong, you might be overconfident. Okay, so let's get to CSGO betting. First, word of warning, if you're really trying to make money out of this, you probably won't, because there's so much shady stuff going on with bookmakers. If you start winning for real, make some money, you're probably gonna get banned, your funds are gonna be frozen, and good luck like suing some company in Cyprus. So please don't do it like if you real money, just do this academically. Don't make my mistakes. All right, let's talk about like what we actually did. First, a show of hands, like who knows what is CSGO, Counter-Strike Global Offensive? Okay, most of you already know about it, so I will be very, very quick here. It's just a multiplayer game. It's like the matches are teams of 5 versus 5, play like on different maps for a number of rounds. The details don't really matter. This could be any kind of like team sports. Could be soccer, for example. The only difference that CSGO, well, especially at the time, was a much more immature market with a lot of data available, while soccer is extremely mature and efficient. So that's one of the reasons why we chose CSGO. We had data, and we thought the market was much more immature compared to like traditional sports betting, where the bookies are a lot more advanced. I don't think like this would even be true anymore. So that's also part of fighting the edge. You gotta find some kind of like sport or situation where you believe that the market is particularly inefficient. So here's the summary of what we actually did. First, we built, using Python, of course, some web scraping for match data and for the betting odds. So we managed to find like 30,000 matches of CSGO in the past 3 years. We collected all of them and we extracted hundreds of features for each match. And we managed to collect 3 months of betting odds. Unfortunately, it's very hard to get like a historical data set of betting odds. You can only collect them moving over time. And note that a betting odds is constantly changing throughout like the time before the match starts. So you cannot be naive and just get one betting odd per match. You gotta get the whole time series of betting odds. So as I said, like we created hundreds of features based on this historical data. The most important feature was true skill. I'm gonna talk about it in a second. We did the modeling with LightGBM. You could have used like XGBoost. I think they're pretty good for this kind of tabular data problem. We did a lot of out-of-time evaluation with time series evaluations with metrics like AUC, accuracy, and some calibration metrics. And finally, we did a backtest to calculate the ROI of our bets, of our betting strategy. So here are the top features. What is most important here to see is that the top features are based on true skill, which is another model, so it makes sense. There's some kind of stacking, where one model is feeding another model. And other features are like kill-death ratio, average damage per round. We collect a lot of like individual, like team and player metrics from previous matches based on like a map, based on what they faced before. That's why we spent a lot of time on feature engineering, because our idea was that like if you want to have a better model, instead of spending time on hyperparameter tuning, you should spend time on feature engineering, which is not exactly a good lesson to take from this, because I should have spent more time on the betting strategy, as I'm going to talk later. So what is true skill, which was one of our trump cards, another edge perhaps, if you will. True skill is a model developed by Microsoft for like multiplayer matches. It's like ELO ratings on steroids, like a Bayesian version of ELO rating. And what is nice about true skill is that it gives you like latent variables, like the skill of each player, of each team, gives you the variance of the skills. So more matches means like smaller variance, and even gives you the probability of a team beating another one based on their skills. But why not just use true skills then? Why not just use the probability of winning given by true skills? Well, this is just a side note, is maybe a big fight between like statisticians and ML engineers. But statisticians love simple, explainable statistical models where you can understand what's happening, and you want to infer some latent variable, make some kind of inference, maybe even do some causal analysis. But us machine learning engineers, we care more about predictive power. And this model is more focused towards inference of latent variables and not predicting the results, while something like LightGBM is really trying to optimize like a loss function to maximize our predictive power. So we use LightGBM, as I said. It's super powerful. It can handle missing values, categorical features, all out of the box, all natively. You can use early stopping to determine the optimal number of trees. You can use multiple different loss functions. Here we just use the standard log loss, but you can even create your own custom loss function easily. You can do like interpretability of SHAP or just the standard feature importance. Just a shameless plugin, but I did a presentation at PyData London on how to unlock the power of LightGBM, going into like deep details of every single topic there. I really recommend if you're using either LightGBM or XGBoost in your daily job, because there's a lot more than just like, let's say, fit predict there. The evaluation, as I said, was done in a time series fashion. This is a very broad lesson. Whenever you're doing ML in practice, you always train the model with past data and you predict it on future data. So your evaluation procedure should reflect that, right? If you just like bundle things together and just do like a random cross-validation, you might be overly optimistic because things are changing over time, and this might be the death of your model. So here's one of the results that we found: the accuracy over time. You can see that like the accuracy is way beyond chance. There is a drop between training and test, so there's some overfitting going on. Overfitting on its own, it's not the end of the world. Some people sometimes are too worried about overfitting. What really matters is stat set performance. It's not overfitting. It doesn't matter how much there is a drop. What matters is that your model on new unseen data performs better than other models. That's what we found. But here, a much better baseline than just 50-50 split, which is the class balance of this problem. a much better baseline would have been the betting odds, the probability by the betting odds. But that's kind of hard to like find. And as I said, there are multiple odds per match. So to simplify, I'm just showing the accuracy with the 50-50 baseline. And here's the calibration of the model. It's pretty well calibrated out of the box. No kind of calibration was needed, but if this was bad, we can always calibrate ensemble models post hoc using things like isotonic regression or plot scaling. I really think isotonic regression is the best model for that. So if you have a good model that's it's good at discriminating user samples, whatever, that is, if your model has a high AUC, you can always, even if it's poorly calibrated, use isotonic regression to make it calibrated afterwards. And now it's finally the backtest. The backtest, as I said before, is all about replaying your betting strategy with past data and try to see what your bets would be and what would be the result of your actions. So you want to evaluate all your metrics, both the machine learning ones like accuracy, AUC, calibration, on the bets that you make, not on all of the examples. You also want to calculate financial metrics here. I'm just going to show one, the return of investment, but you also want to calculate risk metrics, for example, Sharpe ratio or the max drawdown. I don't want to bore you finance here, but you really want to understand how your model behaves, not just with machine learning metrics, but also on business metrics. And finally, past performance is not a guarantee of future performance. So even if your backtest is positive, that does not mean that you're going to have the ROI it predicts. And so those are the results for just 2.5 months of data that we had of betting odds. And we had an ROI of around 8 to 10%, depends on the simulation. And there's a lot of uncertainty. You can see the lines that there is a lot of uncertainty, but in all situations, it's a pretty positive ROI. And you got to consider that this is just for 2 months of data, roughly. If you analyze this to a year, you have something like 40% of ROI. That's way more than you can get in the stock markets, way more than you can get from some risk-free investments. Even though the risk is quite high, when you saw that, we realized, okay, we do have an edge here, we can make money, and yeah, you saw what happens. So why did I lose money after all? I'm sorry that there's like no surprise here, like no bug or human error that we found that would explain like the drop. But there are a lot of mistakes that we made, and they mostly relate to financial planning. So first, I had no entry strategy. When I saw those backtesting results, I started to use the half-Cali criterion right away, placing a lot of bets with a lot of money, and it didn't work. I don't know exactly why, maybe it was just bad luck, but there are so many parts of the system. There is, of course, the machine learning model, there's the betting strategy, but also there's like your feature pipeline that gets like match data and transforms into features to fit into the model. There's so many moving parts, even like the act of betting itself, we couldn't automate that due to like terms and conditions. So we had a Slack bot sending like alerts to us when, oh, here's a bet I should make for this amount, for this team at this website. All of this needs to work together in tandem, and you need to make sure that all of this works before actually putting money on the line. And I didn't do it, like sounds very naive, but well, that was 5 years ago. Hopefully I grew a lot since then. And also I didn't have an exit strategy. I didn't know when to quit. I just quit based on vibes. I was just bored of it. But like, if you are really like putting money on the line, you need to know like when you're gonna get out of your like bets. Maybe you wanna quit after a stop loss. Maybe you quit when you realize that your edge became dull. But you cannot just quit on a whim. And I was also like kind of following the machine learning is all you need fallacy. The idea that all you need is a good model with loads of features and a lot of predictive power, and all your problems are going to be solved. But as I just said, like a machine learning model is just one part of a complex pipeline, and you really got to invest in all of the pipeline to make sure everything works. And then perhaps you want to improve the model more, because that could be high leverage. But if you don't have high confidence that the whole pipeline works, there's no point improving the model. So maybe having hundreds of features was like just a waste. We should have started with like just a dozen or so and validated the whole system, and then increase features, model, and increase the bets as well. So just finish and wrap it up. There are some 5 takeaways here I want to raise. First, don't believe anyone tries to sell you an edge, some kind of advantage, some kind of crypto stock, whatever. You got to find it on your own if you really think you can make money. If you use predict proba for any kind of decision making, you got to make sure that probabilities are calibrated. If they're not, you can always calibrate with isotonic regression. If you're bidding for something, could be like a house, a car, or like anything really, consider the winner's curse. The person who's bidding more, who's paying more, probably is most overconfident, most wrong about this action. And finally, focus a lot more on backtesting, risk management, and financial planning than on machine learning. You really must understand how the system works end to end, understand what are your risks, what are the unknowns, do like scenario analysis, simulation, start with paper trades, just shadow modes, gain confidence, prove that your backtest is working, and then slowly increase like the amount of money that you bet. Even like legends in the area, like Ed Thorpe, like his book appeared in one of the slides. Ed Thorpe is one of the first card counters. He made a lot of money in casinos. He made a lot of money in hedge funds. When he was card counting casinos, the situation where you can know exactly the probability of winning, he still did that. He still started with just paper trades. He started very, very small, and then eventually he used the criterion that he's one of the inventors of. And finally, making money with machine learning is quite hard. I would really recommend and encourage just find a machine learning model job instead. And as I said, we are hiring, so come talk to me later. Thank you. Sorry, as I said, like if you follow the QR code, you can find the blog posts for all the content and reproducible notebooks. Yeah.
Okay, thank you for this interesting story, Pedro. Other questions from the audience? See some hands.
So great talk, thanks. I can imagine at some point, you lick your wounds and you kind of go, okay, that hobby didn't go anywhere. Yeah. But part of me also imagines that you're going to look for the next hobby.
Well, I just had a kid recently, so that's my new hobby. And honestly, what I'm working right now is with LLMs and AI, so I may be suspect, but my last blog post before this one was about applying ChatGPT to like some classification task. It was like early last year, so before all the hype. But yeah, I've been investing more like on LLMs and AI now. That's my daily job, and not much on like financial decision making.
I wanted to ask a question about your future, but I think having a kid is more important. So another question, did you look at other casino games? Because I believe they are a bit rigged, or my friends tell me like when you have a wheel, it stops like right before the jackpot. Have you done something with that, or?
The plan was to go to other esports, like League of Legends, Dota, if this was working, but it didn't, so I stopped at CSGO. But there's an article that I read recently about someone that was just doing like American football betting, and they just found like a very simple edge which worked, which was averaging the betting odds across like 30 different bookmakers. And the backtests were amazing. They did like paper trading, live trading, and they got actually a good ROI. But what happens is that like they were essentially like banned for most of the betting houses. So this is what I said: the house is always gonna win. So one lesson that like I'm never gonna make money like in sports betting because it is rigged. No matter what you do, it's gonna be rigged against you. So it's only for fun, really.
It's better to just go outside.
Yeah, exactly. Okay.
With the model you used, is it easy to overfit the data, and how do you avoid it?
Okay, models like LightGBM or XGBoost can easily overfit data. Depends on like parameters like learning rate, number of estimators, but unlike like let's say random forest, they overfit easily. And as I said before, I don't think overfitting is a problem per se. What you really care is performance out of time, out of sample. So if your model is outperforming other models in this fair evaluation, you don't really care that it's overfitting. Overfitting on its own is not a problem. But there are some things you should be worried about, for example, features degrading over time. So I'll probably be doing things instead of like worrying about overfitting, doing something like adversarial validation, which is like, can you use the features to predict training test set over time? If that's possible, this means that features are evolving over time in a weird way that your model probably didn't capture. Or another technique which I like is permutation importance, where you shuffle a feature around and you see the impacts that this has on your model. If you shuffle a feature around and the performance improves, this means that this feature is harmful. and or if it's neutral, this means the feature is useless. So I'll be doing things like finding which features are degrading over time or being harmful and try to remove them rather than worry about overfitting per se.
Thanks.
Hi. You mentioned something called isometric regression when you talked about calibrating your models. Can you maybe just go a little bit deeper into what that is?
Sure. There are many ways to like calibrate a model. Isotonic regression is very simple. It's a way that if given any kind of curve which is like monotonically increasing, like a score or probability, it's going to make sure that every single point of your curve is going to match the actual frequencies of the data. And it does, as I said, in a monotonically increasing fashion. So when you have a tree-based model, which is all like jagged and the probabilities are not very smooth, this is a very good fit because it's only going to map like if the model says probability is like 0.1, but that in your validation set was actually 0.2 probability, it's just going to do this mapping from 0.1 to 0.2. And just does that in a monotonically increasing way. So it's just very simple, very empirical, no models like model-free. You just got to make sure that you do it on a validation set, not on your training set, or like it's going to be learning something like not true.
Okay, thank you.
One more question. Can you give the microphone to the person in the microphone?
Thanks for the talk. I noticed in the plot with the feature importance that for most features, the team 1 weighed heavier than team 2. Could you maybe explain why that was the case? You would expect them to be the same, right?
Yeah, there's like no house advantage in CSGO. There's no such thing. And actually what we did was, I didn't mention this, but to do some kind of data augmentation, we swapped all features of team 1 and team 2 like for every single match. So every single match appeared twice with team 1, team 2 inverted. And then during prediction time, we'll do the same, make 2 different predictions with the features like swapped, and then take the average of the 2 predictions. That gave a lot of like double the data, so it was quite important because we're kind of data hungry. But now answering your question directly, I don't know exactly why this led to like some features being important from team 1 be more important than team 2. Maybe there's just a lot of like redundancy there, and the model just by luck capture one more than the other.
Thank you. So we're running out of time now. The next talk will start in 10 minutes. Thank you, Pedro.
Thank you.